Hey everybody, this is Larry. This is February 17 of the LeetCode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. And yay, we have a treat. And I say that because we haven't done this daily problem before. Or by we, I mean me, so maybe you have done it at home. 783 minimum distance between BST nodes. Hit the like button, hit the subscribe button, join me on Discord. Maybe I already said it. For the two of you who are curious about my squatting adventures, so my end of year goal is 315 pounds, or I think 100 kilos, right? No, that's not right. Wait, is it? 315 pounds, 2 kilos. Okay, 140 kilos. Okay. An American education system and rating system, am I right? So that's my goal for the end of the year. The stretch goal being doing 315 or 140 kilos for reps. Today, so I rested for about the last week just because I feel like my central nervous system has been a little bit tired and all this stuff. But today I finally able to, or not able to, but I finally returned today, and I'm glad to say that I've done. I did a 290 rep, which is. That's not right. Sorry, I don't know all these conversions. 130 kilos, so I'm like almost there. 130 kilos or so to my goal. And I repped, what did I rep? 265, which is 120 kilos for 4 sets of 5, in case you're wondering. So I'm trying to, stay a little bit healthy and, getting old. So, things just all that stuff. Anyways, if you have no interest in Larry's fitness adventures, my apologies, but let's get started. Okay, minimum distance between BST nodes. So we turn the minimum distance or minimum differences between the values of any two different nodes in the tree. So you have 4, 2, 3, 1, 3. So 1 and 2 is 1, and maybe 2 and 3 and so forth. 2 and 100. Okay. So, I mean, now there's another problem. I mean, obviously there are a couple of ways you can think about doing this. I think the one of the biggest thing is noting that this is a binary search tree, meaning that if you do an in-order traversal, it is just between two adjacent numbers, right? So we can kind of do that, and some of the more smarter people, or not smarter necessarily, I mean smarter as well, and beautiful. Some of the good-looking fans might have know that Morris Traverso can do this in even though it does some funky stuff. Then you can do it and just check by the, adjacent things. I think we could do that. I mean, and then you could do it in kind of all one extra space or something like this, even though you modify the links and then you have to modify back and stuff like this. But anyway, so let's get started. I mean, I think I'm just going to do this recursively. With these kind of binary search tree problems, the thing that I just like to do is just return the smallest on the left side, and then from that, it should be good to calculate. Because everything else, everything else should be okay. I mean, obviously, you could also, because right now, if we do like a regular traversal of the tree in order, say, then this is going to take all of H space, where H is the height of the tree. You could make an argument that, in the worst case, the height of the tree is O of N, which is linear, of course. And then you can maybe do something linear space. But of course, H, or the height is a tighter bound for a lot of things, right? So, All right, let's do that. So we have a traverse of a node, right? And this returns the smallest and largest number from this subtree, maybe. And then we can use it to kind of play around with it. And then here, maybe we just use an answer. I don't know. Answer is the delta, and maybe we just set it to something ridiculously big, right? yeah, if node is none, we return. But we should actually just do a check for if node is leaf, which is if node.left is maybe return none, because this should never happen unless the tree is empty, which yeah shouldn't be. If node.left is none and node.right is none, then that's our actual base case. We return node.value, right? And then yeah, and then otherwise left is equal to node.left, right is equal to node.right. These are the answers, and then basically what do we do? We want to return the smallest number. Wait. Oh yeah. The smallest number is just gonna be left dot or left of 0, which is a little bit awkward, and right of 1, right? Because the right will contain all the bigger numbers and this will contain all the smaller numbers. So you want the smallest of this one and then the larger of these one, right? So that should be okay. This is not done yet, of course, but I just want to go over it really quickly and then just return ands. Of course, we have to update ands, and then basically, yeah, it should be, the answer should be one of the 3 things, right? Or one of the 2 things. Oh, this is just weird. I forgot the recursion part. But then now we're a little bit lazy. We have to figure out how to handle this a little bit better. We can probably just make it return. The small number would just be infinity, and then the big number is negative infinity. So the sentinel value, if I could get it correctly. And then yeah, and then basically the biggest number on the right minus well the other way around. So ans is equal to min of this, and then it's also the min of right of 0 minus this, right? Basically this is saying, let me run it real quick. Okay. Hopefully, oh man, let me double check that. But what I wanted to say is, basically, this is saying that this is taking the biggest value on the left side, which is the one that's before the current pre-order, and then and then this one is the one on the right. I actually just thought about an easier way to do it. I will upsolve this afterwards. But man, I am getting a Yeezy wrong. Why am I getting a Yeezy wrong? Why is this returning 1? Did I misunderstand this? Like 12 and oh no, I'm returning 16 instead of 1. Okay, so that's fine. Or I see where I made a mistake. I don't take account node.value. So this has to, because this could be infinity, so then it doesn't get counted. So something like this. Because I didn't handle the edge case very well. And also I forgot to handle the starting another day. There you go. Now let's give some it. Alright, there you go. A little bit silliness because I didn't really handle the base case. Very easy mistake to make, which is why you need to test your code, and I didn't. I didn't test my code, and I'm sloppy, so I deserve that, of course. It's a little bit more embarrassing to get a easy wrong on stream, but that's okay. I'm used to being embarrassed. When you have a face like this, what can you do? No, but what I was going to say is that, as we said earlier, like this is fine, right? The way that we did it, and I think it's cleaner, at least in concept and in understanding, because this is a very self-contained function and so forth. But the way that I was going to say is that we already set the answer in the beginning, so maybe I should have stuck to it, to be honest. Which is that because this is a binary search tree, if we do an in-order traversal, it is going to be like on the previous item, right? So that means that if we do it in order traversal, then we can just keep track of the previous item. Something like this, right? So then now, now we just return. We don't care if it's a leaf or not. We traverse the left, and then now we got, or previous is equal to no.value, non-local previous, and also something like this, right? I'm not done yet, hang on. But yeah, but we have to do the math on the answer first, right? So basically answer is equal to min of answer or no.value, and then previous, oh no, this is minus previous because we're going from smaller to bigger, and that should be good. Maybe. Right? Let's take a 1 first. Oh. That is true. Why am I returning no.value and previous is because previous is infinity instead of negative infinity. Okay. So that looks good. Let's give it a submit. That is also good. And yeah. Let's go with both solution. I saw this while I was holding it, and this is technically easier to understand even without Morris traversal. It's just like I said, when we're doing pre-order, we just have to remember the previous thing that we traversed, right? So this is basically what I'm doing here. This is going to be linear time O of H space because, well, you still have the stack space from the traversal. And I think the other one is the same, to be honest. Yeah, because we do 2 traversals, but it's still, only O of H space based on the depth, and yeah, and linear time because you have to look at every node at least once. That's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.